Good night. We continue today with a technology that one sees in a lot of contemporary learning systems. The technology is hints and feedback. And is it adaptive? Well, it can be. There's a rich base of research literature going back decades. There's still a lot of gaps in that literature and promising directions never followed up on. Let's start with feedback. I'll pause for a second so you can read this definition by Hattie and Timperley. So, a student is doing math problems, like what's 3 plus 6, or 2x plus 9 is 13, what's x? And the student gives a wrong answer. What's the simplest feedback we can give them? Correctness feedback, yeah. You're wrong. And the next step up from that is giving the correct answer. The student gets the wrong answer, and we give them the right answer. You're wrong. 7. A step up from that, bug messages. A student makes a common error, and we tell them why that error was wrong. Early work in intelligent tutoring systems, Van Lane, attempted to classify every possible bug and the reason it occurred, and oh my gosh, that was a lot. Just in learning subtraction, 104 bugs. But that raised the question which Van Lane himself answered, Van Lane being a good scientist, are all these errors important to specifically correct? And the answer in part is that, yeah, there are some stable misconceptions or preconceptions, but they're fairly rare, and they usually need a bigger intervention than a one-line message. And so, the contemporary use of bug messages, early on they were used for misconceptions, now they're typically more used for a quick and easy to repair issue, like working in the wrong part of the user interface, or using the wrong in units, or the wrong type of answer. So feedback, is it effective overall? Yes. Hattie and Timperley reviewed 12 meta-analyses, which in total review several hundred studies, and yes, it's effective. But is all feedback effective? No. Wisniewski and colleagues re-review that literature and find that feedback can vary greatly in effectiveness, and they recommend against even asking the question, is feedback effective? Instead, we need to think about which feedback. So, here's one of the variables feedback can differ in terms of: delayed or immediate feedback. Should we tell the student that their answer is wrong right away, or should we give them time enough to figure it out on their own? This is a debate going on since Pressey and Brackbill in the 50s and 60s, and it's still ongoing, with Metcalf and colleagues saying delayed feedback's better, and Liu et al. And Heffernan, and in an earlier meta-analysis, Kulik and Kulik saying immediate feedback's better, and then some papers saying, well, actually there's no difference. What's going on here? Well, going all the way back to 1988, before all these studies arguing one side or the other was right, Kulik and Kulik said that it really depends on the design of the study. And that still seems to be the case today, with most studies on one side of the debate or the other poking at methodological flaws in the other side. To give just one example, Liu and Heffernan and colleagues discovered that there was a longer time between the hint and test for the immediate feedback than the delayed feedback condition in Metcalf studies, and replicated those studies with equal time of test, getting the opposite result. So, in other words, it really seems like a lot of this debate back and forth just comes down to how you design your studies. Going beyond that, Hattie and Timperley talk about different levels of feedback, including task performance, the process of understanding how to do a task, regulatory or metacognitive processes, and feedback on the self or the personal level unrelated to the specifics of the task. They find that the feedback on task performance is generally effective, but better when high level rather than extremely specific. And one example in Hattie and Timperley, telling students how many degrees off their logo solution was, a very fine-grained, very specific piece of feedback on task performance, leads students to focus on tweaking rather than on deeper problems and deeper understanding. They find that the most useful is simple feedback on simple problems. How about feedback on task process? They find across the literature that supporting students on detecting their errors is beneficial, and that helping students learn to identify cues that help them to determine how to solve the problem is also beneficial. A few notes from Jean McKendry's work. She found that feedback was more effective when it helps students understand when a procedure applies and when it doesn't apply, and when it helps students see how to break down a problem into steps. And an example of this is seen in the adaptive scaffolding of error detection or correction seen in Santosh Mathan's work. That work found that when a student makes an error in creating a formula, the system leads the student through realizing that formula is incorrect and then inferring why the result is different than what was expected or desired. So in other words, rather than telling the student that they're wrong, scaffolding them and developing the skill in correcting the errors themselves. This is a picture of Mathan's help-based system. I'll pause for a second for you to look. You know, it occurs to me I could just be asking you to pause the video. Maybe that's smarter. Maybe I'll do that going forward. I don't know. The results? It led to better learning, better transfer, and better retention of knowledge over time. That process of scaffolding students in learning to correct their own errors actually leads to deeper understanding, and that leads to all these forms of more robust learning. Feedback on self-regulation. Some key review findings. It's effective if it helps students devote more effort to the task and target their effort better. It's effective if it helps students know how and when to seek help. And it's effective if it increases self-efficacy, but praising students for their ability usually has negative effects. So even though you're such a smart group of learners, I mean, you folks are so smart, and so likable too. Really, I should be giving you feedback on your hard work, your intensive effort, and your good self-regulation process. So thank you for your hard work in studying these videos deeply and participating in the activities. Thank you for thinking deeply about the videos and putting in the real effort and the strategies to kind of review them and consider what you're being taught and to self-explain it to yourself. Let's move on to hints. Hints are on-demand learning supports. And by the way, the term hint and help are used kind of unfortunately interchangeably in the intelligent tutoring systems literature. So be on the watch for that. The simplest version of hints, simply telling the student the answer. And this is often called a bottom-out hint. Another simplest version, kind of equally complex, is to offer a single tip on demand that doesn't give away the answer. As far as tips go, there's a lot of ways one can give a tip, as Cecily Heiner showed in her work, with different implications for learning outcomes. For example, in young children learning to read, telling them the meaning of the word they're trying to read helps more than breaking down the word into syllables. Some systems also offer multi-level hints, multi-step hints, which the student can click forward at each level. In these cases, as recommended by Anderson, often the early levels orient the student towards the task goal, the later levels explain the process, and then there's a final bottom-out hint at the end to prevent the student from just floundering endlessly. Here's an example of this from O'Lavin et al. People have moved forward from this to look at the possibility of interactive hints, hints where the student has to actually do something at every step, to take part in the process of learning. Arroyo and colleagues showed that there's mixed results for these. They found that interactive hints worked better for girls, but worse for boys. In an attempted replication by Zach Pardos and his team, they didn't find that pattern. They just found that interactive hints were no better for boys or girls. Jury's kind of out with 2 studies. Some people have also tried video hints. Here you see an example from Ostrow and Heffernan, where the student gets a hint in the form of a video explanation. They found that video hints were associated with better learning. There are some clear advantages, like gesture and interacting with the whiteboard, that are going to be more useful in some cases than others. Either way though, still video hints aren't heavily used, probably because they're relatively expensive to make. Some people have experimented with using deepfakes to make video hints at scale. So far from what I've seen, they still look a little bit awkward, but that's getting better all the time. It's not just whether you give the student a hint, it's how they use them. And hint use can be either effective or ineffective. In O'Lavin's model of help seeking, there are 5 steps. First, you have to become aware of the need for help. I need help. Second, you have to decide to seek help. Third, you have to identify potential helpers. Fourth, you have to use strategies to elicit help. And then fifth, you have to evaluate the help-seeking episode. Here is a diagram of O'Lavin's model, which again I would encourage you to go through in detail, kind of step through it. The paper does a good job of describing it as well. And here is O'Lavin's taxonomy of help-seeking bugs. And you can see here that they break down into different kind of bugs involving hint use, bugs involving the glossary in that system, bugs involving making errors. And Alavin's model kind of maps a few of these categories map to gaming a system, the goal of trying to get through that learning. Alavin finds that the different types of help seeking have different correlations to learning, with help abuse, clicking through the hints to get the answer at high speed, being strongly associated with negative results, but rapidly answering incorrectly, not correlate that way. Interestingly, other work has found that behavior of rapidly, systematically guessing is, and part of that comes down to Alavin's tri-step abuse is any case where the student answers too quickly, which could even involve correct answers. That encompasses gaming the system, where you systematically guess to get the answer, but clearly gaming the system, systematically guessing, is a more complex behavior. So just answering really quickly, not necessarily bad for you, but systematically guessing to get the answer without learning, bad for you. They also find that help avoidance is negatively associated with learning outcomes. That, by the way, is something that hasn't always replicated. And so they kind of broke this down. It's a nice paper, not quite the final word. Ito, Roll, and colleagues attempted to build on Alavin's help-seeking model by creating an automated tutor of help-seeking. And here you see an image from it. Now, this automated tutor actually provided to students messages when they committed bugs according to Alavin's model to try to get them to engage in more appropriate help-seeking behavior. Roll and colleagues found that using this approach led to better help-seeking behavior in terms of Alavin et al.'s prescriptive models, and that those changes in help-seeking behavior persisted even in entirely new content. So when the help tutor went away, students still engaged in the more positive behaviors. However, rather disappointingly, it had no impact whatsoever on whether they learned the domain content. Compared to this classic work, recent work has continued to advance in terms of hints and feedback, moving on to auto-generation that can provide hints and feedback at much greater scale and complexity than was possible for human beings to author. And this recent work in particular has used large language models to automate the creation of hints and feedback. Some of these papers have shown that this leads to better learning than feedback in existing learning systems, Pankowitz and Baker. Other papers in this space have found that it leads to worse learning than hints authored by expert human tutors, Pardos and Bhandari. And Nguyen et al. Found that it's better for concepts and skills. This work, in other words, has a kind of complex picture that we haven't really teased out yet. And probably it's going to, again, let's go back to Hattie. It's going to come down to not, is automated generation better? It's going to come back down to, when is automated generation better? And one of the clear things is that this kind of approach has the potential to make it a lot cheaper to author hints and feedback. In particular, making it possible to give a much broader range of types of hints and feedback. For example, Pankowitz and Baker literally created like dozens of different automated messages for student errors during programming. So let's wrap up today with some takeaways. Feedback is good, but it matters what kind of feedback you give. Hints are good, but it matters what kind of hints you give and what the student does with the hints. So this is a seemingly straightforward topic, but there's still a lot to be done. Thank you.